Hello everyone, today in this video we'll be discussing the module 2 of ADA PCS 401, and in this module we have the topics I've taken from the syllabus here, and if you watch this video till the end easily you can score more than 80% marks. I'll be telling you what all you need to know from the exam point of view, so make sure you watch this video till the end, and before starting please do like and subscribe. If you have any questions you can DM me on Instagram. So the first question is, okay, basically we have three topics here. First is the brute force approach methods. There are two methods here, traveling salesman and knapsack problem. Then we have decrease and conquer. There we have insertion and topological sorting. In divide and conquer we have two main algorithms, merge sort and quick sort. Then we have binary tree traversals, and then we have matrix and Streisand multiplication. Okay, so let's discuss each one by one. The first one is exhaustive search. In this two problems are there, traveling salesman problem and knapsack problem. What do you mean by exhaustive? Okay, suppose someone told you to run 10 kilometer. How many kilometer they told you to run? They told you to run 10 kilometers. Okay, so when you are running 10 kilometers, what you will get? You will get tired. Another word, what is called the another word for tired is called exhausting. Okay, so in this algorithms what we do is we try to do it all brute force. Okay, like manually we use apply to do. Okay, so for example there is a bucket of 100 elements. Okay, and you want to find one element. Okay, and what you will be doing, you will be checking each element one by one. So 100 elements you will be checking, and then you will be getting one element. Okay, then that is called as exhaustive search, because you are not applying any algorithm, you are just directly searching all the elements if it is the correct one or not. This is called as exhaustive searching. Okay, in that the first one is the traveling salesman problem. Okay, what do you understand with the term traveling salesman? Okay, a salesman is there who wants to sell its products or something, and they are traveling it. Okay, so they are called as traveling salesman. In this problem, what is the thing is there are n cities. Okay, like New York, London, and so on. Okay, so those are 10 cities are there. The traveling salesman has to go to each city and sell its product. Okay, now what is the thing is find the shortest tour through n cities with the least travel cost. Okay, so the cost should be minimum. It is a very important combinatorial problem. Combinatorial means if there are three buckets, bucket 1, bucket 2, bucket 3, how many ways this can be arranged? It can be arranged 1 2 3, or it can be arranged 2 3 1, it can be arranged 3 2 1, it can be arranged 3 1 2, and so on. Like 6 ways are there, right? So how many combinations can be found to find in those combination which is the shortest tour? Shortest tour means suppose that I am in place A, and in place B it is 10 kilometers. Okay, and here it is 5 kilometers, and here it is 2 kilometers. The shortest path will be 2 and 5, not 10, right? So 10 will be more, 2 and 5 will be smaller. So I'll be going to the city C, then I'll go to the city B, right? So the way in which we find out the answer so that it is the shortest, that is called as traveling salesman problem. So this problem we will be solving it using the exhaustive method, because there is no known algorithm which can solve it in shortcut. Okay, we have to go to each city and check what is the travel cost. See here, 4 cities are there, A B C D. Okay, and from traveling from A to B is cost is 2. Okay, means a taxi will take you from A to B and it will take you 2 rupees, and another taxi will take you from B to D, that cost is 3 rupees. So I want to travel all the cities and have to find out the least cost. From A, I have how many options? I can go to C, I can go to B, I can go to D. And again, whatever I choose, if I choose B, I can go to C, then I can go to D. I have another choice. If I go to D, again I have choice. I can go to C, I can go to A, right? Like that. Okay, for each point I have choice, and the starting point also I can choose any. So I have to select which tour will be the shortest one. Okay, so we'll be checking all the tours cost. First we'll be starting from A, then we'll go to B, C, D, A, again A. If I go like this, A, B, what is this? A, B, C, D, A, right? So A, B, C, D, A. If this is the path I'm choosing, okay, I'll draw. Again, this is the path if I'm choosing, my cost will be 18. If the other one, which is A, B, D, C, A, A, B, D, C, A means what? A, B, D, C, A. If this path I'm choosing, I'm getting 11. So like that, all combinations I'll be seeing, and I'll be choosing the minimum path. So two minimum paths are found here with the 11 cost. Okay, so these are the answers for the traveling salesman problem. This answer is found after calculating all the possible paths. Okay, so that's why it is the exhaustive search. Another example is a knapsack problem. Okay, knapsack problem, I'll explain you what it is. Given n items, how many items are there? N items are there of known weights W1 to Wn. Okay, n items are there, and each of these has a weight W1, W2, W3, W4, like 10 kg, 20 kg, like that. Okay, and values V1 to Vn. Value means what? This. Okay, this is of $10, this is of $20, this is of $5, this is of $7.5. So each has a cost associated with that, and it has a weight also. Now we have to find out a knapsack capacity. Knapsack means I have a big basket. Okay, in big basket only 3 things can be allocated, but I have 4 things. Okay, so among these I have to choose which one to include so that my maximum cost will be there. Okay, means the profit will be more. Suppose that I want to go to city. Okay, I want to go to a city called as Arabia. Okay, in Arabia I have to go and sell some items. I have a bag which can occupy only 3 items. I have 4 items in India. Okay, so I have to choose which 3 items if I keep that I can take to Arabia. So basically I can choose the with the costliest 3 items, right? I have to choose the costliest 3 items, but there is another constraint. I cannot choose any 3 items. I have to choose the items in which the weight will also be not crossing the limit. Suppose the weight limit is 10 here and I have 4 items. So the items which I choose, that weight combined should not be more than 10. Otherwise, I'll not be able to carry it. Okay, so these constraints are there. This problem is called as knapsack problem. Okay, so let's take an example here. So the capacity is 10. Okay, I can store 10 kg in the bag, and the first item is of 7 kg with the value $42, and second is 3 kg with dollar 12 as value, 4 kg with $40 as value, 5 kg with $25 as value. I have to choose items such that it will not cross 10 kg and the cost will be maximum. Suppose that I choose this one and this. 7 plus 3, 10, it will come here. 42 plus 12 is 54. So I'm getting $54 if I sell item 1 and item 2, and the weight is also under control. I'm getting $54. Can I have any other combination which will be crossing $54 within the 10 kg limit? If I choose item 3 and 4, for example, 5 plus 4, 9 kg, I am under 10 kg, it's fine. I can take these 2 items. If I calculate its costs, 40 plus 25 I will get. What is 40 plus 25? It is 65. So obviously 65 is more than 54. So instead of these two, I can take these two, right? I can take 3 or 4 also, but the thing is it will exceed the cost, right? So that also I have to keep in mind. So my answer will be item 3 and 4 only, right? This is the optimal one. Other ones are lesser values, or it is not feasible because of the exceeding weight, right? So this problem is called knapsack problem. Here also we are trying to calculate all the possible combinations and seeing which answers we are getting and which is the best answer. So this is also exhaustive search. Okay, exhaustive search. Okay, exhaustive search, two are there: TSP, which is traveling salesman problem, and KS, which is knapsack problem. And these two come under NP hard problems. Okay, NP hard problems are those problems which you are not sure if we get if any algorithm exists which can solve it in lesser time than exhaustive search. That is called as NP hard problems. Okay. Moving to the next topic, we have decrease and conquer. Okay, what is decrease? Decrease means suppose you have a cake, okay, and your sibling came and ate this much cake. What happened? Your cake decreased, right? Your cake, what happened? It decreased. So that is only called decreased. And conquer means what? After decreasing, conquer it. Okay, means I'll explain you what it is. So suppose that a big enemy is there, okay, and the enemy you can't defeat. So what you will do, you will decrease the enemy, decrease the enemy, decrease the enemy, decrease the enemy until you will be able to defeat. Okay, like that. That is called as decrease and conquer. Now there are 3 methods. First one is decrease by a constant. The enemy is there, you first cut his head, then you cut his chest, then you cut his hand. Like that, by a constant you are decreasing. Next is decrease by a constant factor. Okay, factor means what? You will be having a value like 2, then 4, then 8, like that. You keep on decreasing by a constant factor, multiplying by 2 and decreasing. Variable size decrease means sometimes you are cutting the head, sometimes you are cutting the half body, sometimes cutting one leg, sometimes cutting one nail. So like that. Okay, by a variable size it will increase or decrease the amount of decreasing. Okay, so this is the one which is the decrease by 1. Okay, problem of size n is there, then you will make it as n minus 1, then n minus 1 minus 1, which is n minus 2, then n minus 3, n minus 4, like that till you reach 0. So one by one you are decreasing and finding a solution to the problem. So if f of n is greater than 0, make it as f of n minus 1 into a. Else if if n becomes 0, then f of n value will be 1. Okay, because at last it will be 1. Okay, like that. That is decreased by 1. It decreased by a factor which is divided by 2. Like for example, size of problem divided by 2, again divided by 2. When you do, it will become n by 4, again divided by 2, n by 8, n by 16, like that, so on it will go on. Okay, so problem you are dividing by 2, and that sub problem also dividing by 2, and sub problem also dividing by 2. So we'll be getting this value here. Okay, a power n by 2 whole square, and if it is odd, a power whole square into a. Okay, and if it is 0 means 1. Variable size decrease, we can take it the GCD problem, because in GCD we are not sure how many iterations are required to reach the final solution. So here we are using this formula for the decrease, variable size decrease example. Okay, now 2 algorithms are there, very important ones. You have to know the algorithm as well as it's working with example. So let's have a look. The first one is insertion sort. Okay, insertion sort, this is the algorithm. So what is the input we have? We have an input array, and output is what? Output is also obviously an array only, nothing else will be there. Okay, and input will be array, so obviously output also be array. Just the difference is that here the elements are not ordered. In the output we will be having an ordered elements. Now how does this work? Okay, So here two loops will be used. First loop will travel from the first element to the last element. Okay, let's take this example. First loop will run from the first element to the last element. Inside that we will take our element v. V is nothing but the first element usually we will take. Next j we will take, which is I minus 1. Okay, so we will take one element as j, one element as I we will take. Now what we will do, we'll compare. We'll compare what? We'll compare these two values, 89 and 45. Is 89 greater or smaller than 45? Greater than 45, so 45 should come behind 89. So 45 will be put here. Next, again, 68 will be compared with these two. It should come after 45 and before 89. So it will be put here, 68. Then again, it will compare with 90, then 29, then 34, then 17. At last, when we reach, it will be ended. Okay, so inner algorithm does the comparison and swapping. Okay. Next is the time complexity. This time complexity, in the worst case, it will be n square. Why? Because suppose it is not sorted. If it is not sorted, we'll always compare these two. Again, we'll compare these two with this. Again, these three with this. These four with this. So it will become n square. But if it is already sorted, we will compare these two sorted, and we will be reaching the end. So in the best time complexity, it will be n. Comparing an elements, worst time complexity will be n square, because we are doing double for loop for each of these elements. Okay. Next step is topological sorting. Here a directed graph is used. What do you mean by directed graph? A graph which is directed. Okay, this is a node, this is an edge, that is a directed graph. A node with no incoming edges is deleted one by one. Here is an example. So suppose this is the graph given and we have to do the topological sorting. This means what? This means that in which order if I go, I will be covering all the requirements. The requirement is that suppose these are the courses. Okay, this is the biology course, this is the physics, this is the maths course, this is the Malayalam course, this is the Tamil course. Okay, now to complete the C3 course, we have to complete C1 and C2. Otherwise, we can't take up C3 like that. Okay, so we'll have to complete first C1, then we'll complete C2, then we'll complete C3. And to complete C4, we have to first complete C3 like that, then we'll take C4. Or we can directly take C5, but the requirement is C3 and C4 both should be complete. So here what we will be doing, the criteria is to find out the order in which we have to do. We cannot complete C5 directly, obviously, because C1 is the requirement. We have to complete C1, then C2, then C3 will be unlocked, and then C4 we have to complete, then only C5 will be unlocked. So that's why an order is required here. Wherever order is required, their sorting is required. So here the rule is that no incoming edges is there, delete that. Check, is this having any incoming edges? Like this, some arrow you can see? No, you can't see, right? Because it is not there. So you'll be deleting this one. Deleting means take into consideration. So when you take into consideration, you'll be writing it here. Next, see this one. Is there any incoming edge? And once you delete this one, the graph will look like this. Okay, then C3 has one incoming edge only. C2 does not have any, so we'll take C2 and eliminate it. We'll take C2 here. Next graph will become like this. Here, see which has no incoming edges. This has incoming edges. No, it does not have. This has incoming edges. Obviously, this has incoming edges. Yes, two incoming edges it has. So this does not have incoming edges. So take into consideration. So put it here. Then this will be taken, and this will be taken, and finally C5 will be taken. Okay, C4 will be taken, and then C5 will be taken. So this is the solution obtained. This is called as topological sorting. Delete the node with no incoming edges. Repeat with me. Delete the node with no incoming edges and keep on going. Okay. Second topic is divide and conquer. Okay, we'll be dividing and conquering. Okay, if the problem of size n is there, divide into two parts, n by 2, n by 2. Again divide into two parts, n by 4, n by 4, n by 4, n by 4. Then solve all of them and combine it to the original solution. This is the graph you need to make. Okay, so the first one is the merge sort. Very, very important from the exam point of view. You have to remember these 2 algorithms. Okay, let's have a look at what is these 2 algorithms. Merge sort means what? We have to merge and sort. Okay, in order to merge something, it has to be unmerged first. Suppose that I have a cake. Okay, someone asks you to merge this cake. That is a stupid requirement. We cannot merge something which is already merged. So what we do, we will be first unmerging the cake. Unmerging means we will be making it into 2 parts, then we will be merging it. Okay, so this is the graph for it. Okay, so here as you can see, rough by at the top you can see that it is dividing first, then it is merging, right? So let's have a look with the algorithm. Okay, then we'll come to the example. So you have to write here merge sort, and array will be their input, and output also obviously it will be an array, but it will be ordered array. And the thing which will be happening here is copy first half to B, copy second half to C. Okay, 0 to n minus 2 minus 1 means first half, right? n by 2 minus 1 is first half. First half, take it into a B array. Second half, n by 2 to n minus 1, take it into a C value. So we have a B array with the first half of A and C array with the second half of A. Now B and C are there. then again merge these two after sorting. Check if these two are sorted or not. If they are not sorted, sort it and then merge it. Okay, so again B will be considered. Again the same thing will be called. Merge sort will be called with B element here, like how A element merge sort was called. Now B element will be gone for the merge sort. So what will happen? B will further be divided into two arrays again, and this one again will be called merge sort. This one will be divided into two, until and unless n is greater than 1. Until and unless n has at least two elements. Okay, if it has one element, we cannot divide it further. If it has two elements, then only we can divide. So until this array has more than one element, we will be dividing it, and then finally we will be merging B, C, and putting it in A. After we have merged and we will be sorting these two, then sorting will happen. See, suppose that we divided and we divided many times. So what happened? Only two elements are remaining, 6 and 7, and here two elements are remaining, 8 and 9. Is it sorted? Yes, it is sorted. Both are sorted. Then merge these two, so it will become 6, 7, 8, 9, like that. Okay, so in other words, if the elements were 8 and 6 and here it was 9 and 7, now 8 and 6 first sort it, so it will become 6 and 8, and 9 and 7 will become 7 and 9. Merge it. When we merge it, 6, 8, 7, 9, it will become 6, 7, 8, 9. When you merge, then we have to check. After 6, 7 comes not 8. So we will not write 6, 8, 7, 9 like a stupid person. We will be writing 6, 7, 8, 9 after checking the actual elements. So where is the checking happening and where is the ordering happening? For the ordering of the elements, merge will be used. So this array, this function will be used where we will take B and C arrays and we will be checking each element in which order it should be taken, and that whole order will be sorted and put in A. So this is the code for that. Okay, checking if I is less than P and J is less than Q. Okay, what is I and J, what is P and Q? Two arrays will be there, right? B array and C array. So here I will be taken and P will be taken, here J and Q will be taken. We will be comparing the small and greater elements, and then we will be comparing and we will be making the changes, swapping it. Okay, so here whenever we are done with the swap, we will be copying the first half to A and the second half to the second half of A. Okay, like that. So after doing that, we'll be merging it, and finally when we keep on merging, we'll be obtaining the final array. So let's take an example here. 83297154 divided into two parts. We'll get 8329 again divided into two parts. 8329 divided into two parts, 8 and 3. 8 and 3, when we merge it, it will become 3 and 8, right? This is the way. 8 is smaller or 3 is smaller. 3 is smaller, so we'll put 3 here. Like that, do for this also. 2 and 9, 2 and 9. 7 and 1 will become 1, 7. 5 and 4 will become 4, 5. 3, 8, 2, 9. Compare all these. What should be the order? It should be 2, 3, 8, 9. So 2, 3, 8, 9. Compare the order and tell me what it should be. 1, 4, 5, 7. 1, 4, 5, 7. And then again, each of these will be compared. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this one will be the situation. This is the how the merge sort works. First you unmerge it, then you merge it. Okay, like a diamond, you can remember. Unmerge, then merge. Okay, this is a merge diamond. Okay, now second one is the quick sort. Quick sort also does the same thing, but here we'll be having a pivot element. Pivot element means what? This is the array, and we'll be choosing one element here in between, and this element's left part should be smaller than that and greater than this one. What I'm trying to say is, whatever the element you have chosen here, in between we will choose an element, and then we will sort this part and this part, and this element which we choose, that should be such that all the elements present here should be lesser than this. If this is 10, all the elements should be less than 10, and here it should be greater than 10. Like that element we will choose here, and then we will sort it. While sorting, again we'll choose a pivot element, and then we'll ensure small elements are here, greater elements are here. Again we'll choose a pivot element here, small elements here, greater elements here. Like that, if we keep on doing till the end, what will happen? Behind each element will be smaller element, and above each element will be greater element, and when it is applied to all the elements, it will be a sorted array. Okay, so the algorithm, you need to remember these two algorithms. So first we'll take an array here, and then what we'll be doing, we'll be finding a sub array. S is the partition. Okay, partition where we have to do, if this is the array, if I put here S, if I put here, this will be first half, second half. This will be gone to quick sort. This one again will be gone to quick sort. Okay, recursively we'll call. Again for this, S will be found, quick sort, quick sort. S will be found, quick sort, and so on. It will happen again. Now, when we reach to the end, okay, means we have just one or two elements left, and pivot element is there. How do we actually sort it? We actually sort it using this one. Again, the same thing. I, L, J, and R will be here. Okay, I and L, J and R. We'll keep on comparing. Okay, until we get the elements. When we get an element which is smaller than the middle element, we have to swap it with the element which is greater. Okay, if I take an example, you'll understand. Okay, this is the example of quick sort. Okay, so see, these are the elements present: 5, 3, 1, 9, 9, 8, 2, 4, 7. Okay, now the highlighted element is called the pivot element. Okay, now I will be in the first element here and j will be in the last element. Now 3 and what is the actual comparison we will be doing here? Okay, observe carefully. The actual comparison in quicksort what we'll be doing is 5 is here. Okay, now the criteria, I element it should be smaller. I element whatever is pointing to this, it should be smaller than this, and the j element should be greater than 5. Okay, greater than 5 should be the j element, lesser than 5 should be the I element. Again I repeat, I element should be lesser than 5 and j element should be greater than 5, and 5 is the pivot element. So basically pivot element, I should be less than pivot element and j should be greater than pivot element. I pj, if it is in this way, it is cool and fine, move to the next element. Okay, got the point. Now 5, 3 and 7, I is lesser than p and j is greater than p. Cool, move I to the next position. 1. Okay, again less than 5 it is I and greater than 5 it is 7. So again cool, move to the next element. Check 4. Is 5 lesser than 5 is 1? Yes. And greater than 5 is 4? No. You observed here, the thing what has happened is first criteria is fulfilled, I is less than 5, but is j greater than 5? No, j is not greater than 5. One criteria is unfulfilled, but still one criteria is fulfilled. If both criteria get unfulfilled, then we have to take some action. Okay, so until both criteria get unfulfilled, we have to keep on moving. Then we will check this one, 9. Okay, we'll move I to here and we'll check 9. Is I lesser than 5? Is I lesser than 5? Unfulfilled criteria. I is greater than 5. Is j greater than 5? J is greater than 5? Not greater than 5. Unfulfilled criteria. Whenever there is an unfulfilled criteria on both the sides, you have to swap this and this. Okay, done. 4 came here and 9 came here. So I is 4 now and j is 9. Now check. Is I lesser than 5? Yes. Is j greater than 5? Yes. So when it is yes and yes, move the elements. Okay. Now let's keep 4 here only and we'll move the element j. Or whatever you want, you can move. Okay. You can keep 4 here or move j, or you can keep j here and move 4. Okay. Whatever is the case, if you compare 4 and 2. Okay. 4 and 2 is this criteria matching. Lesser than 5, it is successful. Greater than 5, unsuccessful. Okay. We have to find out both unsuccessful, right? So we'll move this one. When we move this, we will get 8 here. Lesser than 5, unsuccessful, because 8 is greater than 5. And lesser than, greater than 5, unsuccessful. 8 and 2 are unsuccessful. So we'll swap 8 and 2. So 2 and 8 will come here. Now, after that, again we will check. Lesser than 5, yes. Greater than 5, yes. So both are yes means move further. Move further means I will be taken here, j will be taken here, and the point when I will cross j, at that time what we have to do is basically we have to swap the j with pivot element. Okay, we'll swap 2 with pivot element. So 2 came here and 5 came here. So basically what you can observe is a beautiful solution where we have all these elements lesser than 5 and all these elements greater than 5. This is what the situation we had required. The first requirement, pivot element, when it is there, lesser than this all the elements should be here, and greater than this all the elements should be here. So lesser than 5 all the elements are here, greater than 5 all the elements are here. We have reached this solution. After this, sort this one and sort this one. Again what will happen, the same thing will be applied. A pivot element will be taken and the comparison will happen. For example, 2 will be taken as pivot element, less than 2 should be I and greater than 2 should be j. Less than 2 it is not successful, greater than 2 it is successful. So we'll move the this value here. Okay, and then we'll compare this one. Okay, 4 is successful, so we have to move it to 1. Then we'll compare. Lesser than 2, no. Greater than 2, no. When it is no and no means we have to swap these two. When we swap these two, it will cross this value. When it crosses this value, swap the j value, swap the I value with 2. Okay, swap the I value which is present in the left. Okay, always you have to swap the value which is present in the left. Okay, once I crosses this value, what will happen? I will become 3 and j will become 2. J will become 1. Right. See, till this point we had compared less than 2 it is 1 and greater than 2 it is 3. Okay, means I is less than 2 and j is greater than 2. It is fine. Then we'll swap, take further. I will come here and j will come here. When it crosses, whatever is the value of j here, that should be swapped with pivot element. So this one value will be swapped with pivot element. Pivot element is 2. It will be swapped. So 2 will come here and 1 will come here. And then this is a beautiful solution where we have lesser than 2 elements here and greater than 2 elements here. Like that, again this is sorted now, 1 2 3 4. We are need not concerned about this. 3 and 4 again we will check, but it will not make any difference because 3 and 4 is already sorted. Like that we'll do here also, and then we'll reach a solution. Once we reach a solution, we'll have a solution 1 2 3 4 7 8 9, and that will be my final answer. Okay, this is how the quick sort works. Okay, quick sort, very important from the exam point of view, and make sure you know the algorithm very well. Okay, next is binary tree traversals. What is a binary tree? A binary tree is a tree which has at most 2 child nodes. We have learned in the third semester. At least 2 child nodes, at most 2 child nodes. At most means what? It can have 0 child, it can have 1 child, it can have 2 child, but it cannot have 3 child. So 0 1 2 should be there. Okay, and this is the left part of the tree, this is the right part of the tree. Okay, to find out the height of the tree, we will be returning the maximum height. Maximum height means here we can go to the more depth, or here we can go to the more depth. Whichever is the more, that is the height of the tree. Okay, so what we'll do, we'll keep on going until we reach the end. Both the sides will keep on going. Okay, so here we'll be returning the maximum of left height or right height. Okay, that is the height of the tree. Next is traversals. There are 3 types of traversals: pre-order, in-order, and post-order. This also we have discussed in the third semester. Pre-order means what? Pre-order means NLR, node left right. Node left right means if I have to find out the pre-order for this one, N means node. Node means print this one. Printing means put it here. Then go to the left. NLR. NLR means go to the left. Again here NLR will be applied. Again N will be taken, B will be taken, and again L will be there. L means go to here. NLR will be applied. So N will be taken, D will be taken, and again NLR will be applied. L we will go, will not get anything, will come back. NLR, N and L is done. R is remaining. R means go to the right. When we go to the right, G will be there. Print G. NLR will be applied. Come back. L is done for this. Go to the R. R, E will be taken. E will be applied. And then come back. And here NL and N and L is done. Go to the R. Then again apply NLR here. C will be taken. Go to NLR, apply here. F will be taken. So C and F will be taken. And come back. A is already taken. So this is the pre-order. NLR is the pre-order. And L and R is the in-order. LRN is the post-order. So where we will go left first, or we will print the node first, or we will go to the right first. Based on that, 3 orders are there. Okay, this type of traversal is called the binary order traversals. Okay, next topic is the multiplication of large integers. Okay, to multiply large integers in a short form way, we'll have to there is a formula. Okay, for example, if to multiply 23 and 14, so what is 23? 23 is nothing but 2 into 10 plus 3 into 10 power 0, right? 2 into 10 is 20 plus 3 into 10 power 0, which is 1. 3 into 1 is 1. So, 3 into 1 is 3. So, 20 plus 3 is 23. So, 23 can be written as 2 into 10 power 1 plus 3 into 10 power 0. 14 can be written as 1 power 10 in 1 into 10 power 1 plus 4 into 10 power 0. So, these 2 elements are there. When you multiply them, we can write 23 into 14 as 2 into 10 power 1 plus 3 into 10 power 0 into 1 into 10 power 1 plus 4 into 10 power 0. Now, when we do this, 2 into this plus 2 into this plus 3 into this plus 3 into this, like that if we do, and we will take 10 power 1 common, we will be obtaining this value here. Now observe carefully that 2 into 4 plus 3 into 1, okay, that can be written as 2 plus 3 into 1 plus 4 minus 2 into 1 minus 3 into 4. This one you can verify. So this value which is in the middle, that can be written as this value. Okay, so that will only be substituted, and that will help us in finding out large number multiplication in smaller values, because there will be redundant multiplication. Here I am taking it common. Okay, so this is the generalized form where we have C1 and C2. C1 is the first half of the answer, C2 is the second half of the answer, and A1 is the first half of the first solution, and B1 is the second half of the number. I mean, A1 is the first half of the number, A2 is the second half, and B1 is the first half, and B2 is the second half. Here they have taken B1 and B0. So first digit, second digit, and this is the first digit, second digit. Okay, like that. So if we keep on taking it to the higher levels, we'll be obtaining a general formula, which is general formula is C2 10 power n plus C1 10 power n by 2 plus C power 0. Okay, so this is the recursive relation which we get. Okay, you just have to write this one's values, write 3 times, you'll be able to understand it and keep in mind. Okay, last one is the Streisand's matrix multiplication. So what is a matrix? Matrix is nothing but rows and columns will be there, and multiplying it with another matrix will be getting a final matrix. So this one can be reduced, sometime can be reduced using Strasson's method. So principal insight of this algorithm lies in the discovery that we can find out the product C of two cross 2 matrix A and B with just 7 multiplication instead of 8. Initially if we multiply, it will be 8 multiplication, right? Because this element will be multiplied with this row, this element will be multiplied with this row, this one will be this row, this one will be this row. So basically what happens, it will be 8 multiplications, but here in Strassen we'll eliminate 1 multiplication and 7 only will be required. So this value, whatever we get in the final answer, that will be m1 plus m4 minus m5 plus m7, and here it will be m3 plus m5 and so on. What is m1, m2, m3 and so on? M1 is a0 into a0 plus a11 into b0 plus b11. So a0 is this one, and plus a11. Add these two values, multiply it with the addition of these two values, that will be obtaining m1. Like that, 7 things you have to multiply and keep, and you will be getting 7 values. Substitute those values in this equation to find out the final matrix solution. This is called as matrix multiplication. In exam you have to write just this much, you will be obtaining full marks. Okay, and asymptotic efficiency is given here, you can go through it. This is denoting how much time it will be required. So the number is less than n cube, which is n power 2.8. So n power 2.8 is less than n power 3, right? So time will be required less here, and the recurrence relation is this one. This also you can by heart and keep right in the exam at the end. Okay, that's all for the ADA module 2. And if you found this video helpful, please do like and subscribe. It helps me make more videos like this. And don't miss any of these questions. And thank you so much for watching. I'll see you in the next one.